about halfway through is where it picks up. All right, so in the beginning, they just ask you to, it's identification. You'll fly through these first 8 questions like super quick and easy. Let me just write them out. You probably already know most of these. Basically, that kind of a graph, you know, the U shape, what function makes that happen? That's y equals x squared, right? And here, I'll just write x squared. They're all y equals something. It's just, that's x squared. Anybody know what's the square root of x? What does that look like? I'm just going to give you 6 basic graphs. And it's good to put them on your 3x5 card with everything else. So what's the square root of x look like? Anybody know that one? Looks like a little firework like that, just shooting off to the right. I think I was thinking of the firework because it's the only graph that stops on one side and then just goes the other way like that. Okay. Now how about, let me just put it over here. Anybody know, do a little graph here for, let me just change up the color. So what about like x cubed? Anybody know what x cubed looks like? Snaky, yeah. He does a little squiggle snake thing. Exactly right. And then what about when you turn that into a root, like a third root? So you see what I'm doing? I'm doing 2 power, 2 root. This one's really a 2 root, right? When there's nothing in the hook, it means 2, as you know. That's why we call it a square root, because of 2 root. Now I'm doing third power and third root. They kind of go together. So what does a third root do? Well, it's actually the snake sideways instead of vertical. Like that, sideways snake. So it's good. We're getting ready Thursday. Thursday's our big, Thursday will be a really important day. It's our big graphing day. We'll do sections 2, 5, and 2, really important sections. Challenging, super important for the first exam and for the future of the course is what we do on Thursday. We'll take these basic 6 graphs and then we'll learn to stretch them, compress them, flip them, move them. We'll basically really begin to be able to graph well. And that'll start on Thursday. So the way we do it is we have these basic 6 memorized or on our 3x5 card, and then we do stuff with them from there. So we got those 4. Now 2 more. What are the 2? Oh, absolute value. You know that one, huh? Or maybe you do. What's absolute value of x? What's that one look like? That's a v, huh? Yeah, it's a v instead of a u. It's v. Those are 2 straight lines instead of a no curvature there, just a v, straight lines. Okay, last one's a weird one. 1 over x. Anybody know what 1 over x looks like? It's got a couple asymptote lines. We'll get more into him later. The axes, the x and y axes, are actually asymptotes, which means lines of approach, lines the graph gets close to. And then it has 1 diagonal branch here and 1 diagonal branch there. Branches on the 2 diagonals that get really close there and close down here and close up here and close down there. So those are the basic 6. Those are the basic 6. And so we'll take those 6 and Thursday we'll go crazy with them and we'll flip them and turn them and squish them and compress them and move them. Do all kinds of things. And we'll learn what makes that happen in an equation, where the numbers are sitting that make it do things. And if you really get that section down, you all of a sudden will be able to graph a ton of stuff. Just by looking at it, you'll know generally what the shape is, and that's super helpful in calculus. All right, I better move on. We got to get to some other stuff here. So this one they're asking me, what is that thing? What is this thing? And then they're giving me these multiple choice options here. It's a square, if you can read that. It says square. It's squared. That's just a U shape. It's just squared. That's all they want. Click the button. Next question. So these will be super easy. We've got these basic 6. So they're giving me y, which is the same as f of x, equals 3x. How do you graph a straight line? Remember, you start with what number's out here, which is nothing, so 0. Put a 0 out there. You start at 0. This is just a straight line, right? How do you know that equation is going to be a straight line? It's because everything's first power. It's just y first power, x first power. Nobody's squared. There's no absolute values or roots or anything more advanced. It's just regular x, regular y first power. So you start at 0 right there. Start at 0 right there. And then where do you go from there? 3 over 1, rise over run, the slope, huh? So you go up 3 over 1. So 1, 2, 3 over 1. There's your second dot. So your first dot starts at 0. Second dot is up 3 over 1. Then you just connect the 2 dots. There's the line. So which one is it, A, B, C, or D? There it is. That's how it'll be on the real test, multiple choice. I'm not going to give you a line on the real test. That's too easy. But anyway, there's that one, just getting you warmed up. All right, so let's... Okay. So now we've got y equals minus 5x cubed. So as soon as we see x to the third power, we think of the snake, huh? So let me just do a really brief. What we're going to do Thursday is we look at that and we go, okay, I'm thinking of the snake because that's what x cubed is. But what is that minus 5 in the front going to do to the snake? Is it going to flip it? There's two ways to flip. You could flip it vertically or it could flip it sideways. It could move it. It could squish it or compress it. I mean, how do you know? Well, we don't got a lot of time. Thursday's devoted to all that. So I'll just say really, really quickly, you don't have to know it for now. Well, let me show you what you do for now. Yeah, rather than me say stuff that's not important. Let me say, well, how should you do this in tonight's homework? Just make a table. Just make a table for now. We'll get more advanced on Thursday. But for now, just make a table. And when I say make a table, just plug in the two easiest numbers you know, 0 and 1. Just plug in 0 and 1. You'll find enough information. It's all you need for now. We don't need a bunch of fancy stuff. So let's plug in minus 5 times 0 cubed, which is just 0. So 0, 0. Okay. Let's plug in 1. Minus 5 times 1 cubed, which is just minus 5. So put that on the graph. 0, 0. There it is. Over 1 down 5. 1, 2, 3, 4, 5 right there. So I got 2 dots. Am I going too quick? You good to there? Everybody see what I'm doing? So I did 0, 0. And over 1 down 5, which I found from the table. I just did a simple table where I put in the two easiest numbers I know for x, 0 and 1. Just plugged into the equation, got 0, got negative 5. Put the 0, 0 dot and the over 1 down 5 dot on the graphs. And now, what's going to be really nice about this, I like the way this book handles graphing, it's really good. We know the basic 6, so we know generally that this is a snake graph. So all you need is 2 dots. You don't have to really have more than 2 dots. If you know it's a snake graph and you know it goes through those 2 dots, you pretty much got it, right? It's got to go like this. What else? How else could the snake graph go through those 2 dots? But just like that. That must be it. So it's real nice. It makes you a real strong grapher without a lot of work. You just have to know the basics. Couple dots. You know what that thing looks like. So which graph is it? Looks like A, huh? Because it even has the over 1 down 5, which is what we have. So that's real nice. Good to there? So just make a little table. What did that negative 5 actually end up doing then? It flipped it vertically. A negative number multiplied will actually flip vertically a graph, and it pulled it up and down faster. The 5 made it 5 times as fast going up and down, and the negative did the flip. So we'll get into all that Wednesday. Okay, give me y, or f of x, is 7 over x. What am I going to suggest you do? Make a table. Just make a little xy table. Plug in the two easiest numbers you know, 0 and 1. Hopefully that's enough. Let's see what happens. And so we get y equals 7 over x, y equals 7 over 0. What's 7 over 0? It's not 0. I hope you know it's undefined. So I'm just going to write no there. And it's important information, not just being silly. That's important information. At 0, he can't go there. Right? 0 underneath is undefined, isn't it? 0 underneath. It's not equal to 0. It's undefined. You can't do it. There's no connection to the real world. So we say no. So notice when I go to graph the thing in a minute, well, right now I guess, when I do the over 0, I'm just going to write no right on that line. Meaning he doesn't touch the x equals 0 line. That's what that's saying. All right, let's plug in 1. So we get 7 over 1, which is just 7. So that means over 1 up 7. 1, 2, 3, 4, 5, 6, 7. So it's right there. We've only got 1 dot. That's enough, though. Why? Because what kind of graph is it? Which basic shape you can see by the pictures? It's the 2 diagonal ones. It's the weird 2 diagonal ones. Well, if you know that, right? If you go back here, it's this one, right? It's 1 over x, except they put a 7 up there. Is all. So it's the 2 diagonals, but those diagonals can be here and here or there and there. It depends on what they do with the flips and all that. So anyway, getting back to it, I have one dot. Well, that's enough, because that means that the branch is up here, huh? And it must be down there. They're always diagonally across from each other. So it's those two spots. It's got to be B, this one right here. They even have the 1, 7 right there on it. So we're good. Is that good? You okay? All right, so just make a quick table, know the basic shape, you got it. So y equals cube root of 3x. So what do? You make an xy table, you put in 0 and 1, plug in 0, y equals the cube root of 3 times 0. Cube root of 0, that's just 0. Right? What times itself 3 times 0? 0. So 0, 0. Let's do the next one. Cube root of 3 times 1, that's the cube root of 3. You could use your calculator if you want and get the number. It's just some really tiny number. It doesn't really matter. Well, yeah, do you guys know how to do that? Maybe it doesn't matter. It doesn't matter. Let's don't do it right now. It doesn't matter on this one. I'll just leave it cube root of 3. It's 1 point something. Anyway, which one of those graphs, you probably can't even, they're so tiny, I can hardly see them. Cube root of 3. Let's graph it. So 0, 0. And then over 1, yeah, maybe we do need 2 on our calculator. All right. Do you know how to do the cube root of 3 on your calculator? It's 3 to the 1/3 power. Do you remember that from earlier math classes? We'll talk more about that later. We'll get into a whole chapter on that. But roots, numbers in the roots are fractional powers. That's what they are. That's 3 to the 1/3 power. That's what I'm doing there. 3 to the power 1/3. So 3 to the power 1 divided by 3. You got to put parentheses around the 1/3. Well, or you can do it this way. If you have one of those newer calculators that shows it like that, then that's fine too. You don't even need parentheses. If you can type it in like that, you don't need parentheses. If it's all in one line, like my older one's all in one line, then you got to do the parentheses. So you should get 1 point something. Here, I'll do it myself and tell you what I get. 3 to the power. I'm getting 1.44. Come grab me after if you have trouble with that. So that's 1.44. So that means it's over 1, up, like here's 1, here's 2. It's about right there. Just under 1.5, you know? Right? Just under 1.5. So, okay, so there we go. We have that. It's right about there. So what does that mean about the graph? Well, what kind of graph is the cube root? Here's the sideways snake. Sideways snake. The third power is the vertical snake. The cube root is the sideways snake. So I say, okay, he's the sideways snake. He goes like that. So which graph looks like that? Looks like D, doesn't it? We good on that? I got to move. Okay, so good. We got 25 minutes. Good. All right, so this is what the section's all about. 9 to 18. This is the hard stuff. This is sometimes challenging for students. Let me try to do hopefully a clear job on this. So definitely at least one. I think there's 2. Yeah, there's 2 of these. Yeah, no secrets with me. There's 2 of these. Well, you'll see it on the prac exam anyway. There's 2 of these on the prac exam, 2 of these on the real exam. These are really important. These are important for calculus. I'm always aiming at what will do you good in the future. These are important in calculus. These come up a lot. So what is it? It's a piecewise function. What it's saying, we're learning to read these things. What it's basically saying is it's saying, hey, I'm a function in pieces, piecewise. That's why I named that. You use x squared for x values less than 0. You just use 1 when x is 0, and you use 3x plus 3 for x values greater than 0. So you plug into different functions depending on the x value. Does that make sense? So here's the first question. F of -1, that's our x. X is -1. So they want me to come up with an answer there. So f of -1. Okay, is -1, is that an x value greater than 0 or less than 0? Yeah, that's less than 0. It's negative, huh? So which function am I supposed to be plugging into for x values less than 0? Hey, can you all see that? Maybe I could write it bigger. You're supposed to plug into x squared for x values less than 0. You're supposed to just say the answer is 1. when x is 0. And you're supposed to say, plug into 3x plus 3 for x values greater than 0. So yeah, so right here's what I'm supposed to plug in for an x value that's negative, that's less than 0. So plug into x squared, and that's just 1, huh? So it's easy to plug in, it's just figuring out which one to plug into. So the answer to that part, the first question, is just 1. Let's do the second question. Next, they're going to say find f of 0. So let's do that. So what's f of 0? So which of the 3 am I going to plug into for f of 0? When x is 0, you plug into the 1. And actually, there's nowhere to plug in. There's no x to stick anything into. The answer is just 1 and we're done. Does that make sense? You don't plug the x anywhere in. It's what we call a constant function. It's just always 1. There's nowhere to plug the x in. The answer is just 1. So remember, yeah, good enough. Let's, and then finally, part C. That was part B. Part C, this was part A. Part C says, what's f of 2? So this, for x is 2, which function do we plug in for x is 2? Well, that's an x value greater than 0, positive. So you plug into 3x plus 3. So you plug in the 2 there. So 6 plus 3, 9. And we're done. So there's that question. It's going to get a lot more advanced than this. This is just like the warm-up. Does that make sense? Identifying which function. We're going to have to graph the 3 in a minute. That's what they're going to have us do. But you see, first off, deciding which function to plug into based on the x value. That's what a piecewise function is, plugging into different functions at different times. Number 12. Okay. Number 12. So let me write it up here a little bigger for you. So f of x equals minus x plus 3 if x is less than 1. It's 3x minus 1 if x is greater than or equal to 1. Okay. Now, I know they're asking me a million questions about domain and intercepts and blah, blah, blah. Really, you should just get the graph. If you can get a pig, which is part C, they're asking me for the graph. If you can get the graph, just do that first. Everything else is cake. Just get the graph, and the rest will be obvious. So I might as well just do the hard part, and the easy parts will be automatic. So let's just do that. Let's just go straight to graphing this thing. Now, how do you graph a piecewise function, a function that's in pieces? Well, you graph it in pieces. You do exactly that. So what do I mean graph it in pieces? Well, go ahead and make a big graph system. And this is the x-axis, y-axis. And then you want to put a dividing line. Question? Well, yeah, I'm going to divide it up. I'm going to divide it up all around the 1. It's all about the 1. So for x values less than 1, so let me go to x equals 1, which would be, let's just say right there. There's x equals 1. Here's 2 and 3, and here's 0 and negative 1 and negative 2 and etc. Right? So I'm on the x-axis. So I'm going to go to x is 1. 1 is the dividing wall. See, it's all about 1. If x values are less than 1, you plug into this function. If x values are greater than or equal to 1, you plug into that function. So that's going to be, let's put that, I'm going to put that in as a dotted wall because it's not really part of the graph there, so it's just going to put in a dotted line. That's telling me to break up the function into 2 zones. So over here on the left, for x less than 1, I'm going to plug in to y equals negative x plus 3 in all this zone. Because that's all x less than 1 territory. And then for x is greater than or equal to 1, I'm going to plug, so for in this territory, I'm going to plug into y equals 3x minus 1. Do you see that? It's 2 pieces of graph is what it is. Because they're telling me which equation to use in which zone. They're telling me for x values less than 1, use this, right? X values less than 1. For x values greater than or equal to 1, use the 3x minus 1. So it's really helpful to just put that right on your graph system, I think. And then we just have to basically do two little graph things and connect them up. Okay, so let's do that. So I'm going to start over here with the left side, and I'm going to make a little XY table. Really, both these are lines, aren't they? These are both linear equations. They're just x to the first power. They're just going to be pieces of straight lines. So I only need 2 dots. 2 dots is plenty. So I need 2 dots in the blue territory. 2 dots. What 2 dots should you get? Well, you always want one of the dots right, bless you, right at the wall. You always want one of the dots right at the wall. Now, I know you might, I would be thinking if I were you, no, wait, Mr. Aaron, it says x less than 1. It doesn't want the equals there. I know it does, but a lot of students think the following way. They think, okay, less than 1, I'll just plug in 0. No. Less than 1 means it's infinitesimally close to 1, but doesn't quite make it there. So in other words, 0.9999999 is part of that graph. Virtually 1. So you really need to plug in 1. And then I'll do 0. Let me hold up. Do you understand? It's really important that you understand what I'm saying there. And let me say it again. So I'm checking right at the wall, right at x equals 1. But what I do for myself, my own notation, this is my own little thing, is I just circle it to remind myself it doesn't actually quite make it to 1. So it's going to be an open dot there. That's what my circling in the table means. Right? So I'm going to say, I want to know where you are at 1. So let me just plug it in. Probably it's too much talk. Let's just plug it in. So plug in the 1 to what? To negative x plus 3, right? So you get negative 1 plus 3, 2. So that means over 1 up 2. Right here, there's an open dot at over 1 up 2. It's an open dot. Why is it open? Because it's only for x values less than 1. Does everybody see that? You're only supposed to be using that for x values less than 1, not equal to 1. So it doesn't quite make it to the wall. The purple graph will make it right on the wall, because the purple graph is for greater than or equal to 1. Right? You with me? The purple graph will hit a solid dot on that wall, won't it? But the blue graph is going to open dot the wall. The mistake a lot of students make is they just start at 0. They just think whole numbers. Don't just think whole numbers. There's a whole bunch of numbers between 0 and 1. So really you have to do 1 because it gets infinitesimally close to 1. Just put an open dot there. Okay, now 0. Plug in 0. Again, negative x plus 3, negative 0 plus 3, y is 3. So over 0 up 3, I wish it wasn't in the way of my graph. So over 0 up 3, it's right here. That's a solid dot. Over 0 up 3, and then just let her go. There's the graph in that section. Everybody see that? What I did there. So let me go over that one more time. What did I just do? I did the left section of the graph. How did I do it? I just got 2 dots right at the wall and 1. That's what I just do right at the wall and then 1 back from the wall. I'm going to do the same thing on the other side. I'm going to do right at the wall for the purple, and then I'm going to do 1 and 2, basically. I'm going to make a table for the purple. I'm plugging 1 and 2. So I always just find 2 dots, 1 right at the wall, 1 away from the wall. Just an easy way to go. So get 2 dots. The open dot is right at the wall because the blue graph is only less than 1, doesn't quite hit the 1. Then this is a solid dot, and then you just connect the 2 dots with a straight line, and the graph goes forever to the left. How do you know? Because it's less than 1. Everything less than 1. So the graph goes forever to the left. Is that good so far? Now let's do the right side. Let's do the purple graph. Stop me if you have questions or comments. So let's do the purple graph. So the purple graph, make an XY table. What am I going to plug in?
1.
1 and 2. Both solid dots, right? Because this is greater than or equal to 1. So it equals 1 right on the money. So I'm not going to, see how I circled my 1, 2 here? Because it didn't really, I knew it was going to be an open dot. Doesn't really hit 1. Just gets infinitesimally. The blue graph just gets really close to it. But the purple graph hits 1 right on. Greater than or equal to 1. So plug in 1, plug in 2. So into 3x minus 1. So 3 times 1 minus 1, what's that? 2. Over 1 up 2. Well, look at that. The purple graph fills in the open blue graph. That often happens, but not always. Try to show you one where that doesn't happen. But see how they both have the same point, 1, 2. So the solid purple fills in the open blue. So in the end, there's just a regular dot there. There's nothing special anymore, since the solid filled in the open. And then plug in 2. 3 times 2 minus what? 6 minus 1, 5? So over 2 up 5, 3, 4, 5, so it'd be about here. Over 2 up 5. And then connect them. Like that. And we're done. Well, let me answer domain, range, all that silly stuff. But is everybody good? That'll be, the rest will be easy. I'll do it with you though, but does everybody see the graph though? Everybody see how, you just do the graph in the 2 different sections. You make a table for each section. You identify which equation you're going to use and which, actually I started with the dividing wall. The dividing wall was at 1. Left of 1, I used the negative x plus 3 equation. Right of 1, I use the 3x minus 1 equation. I plug in a point right at the wall and 1 off the wall. Right at the wall and 1 off the wall. And then just let it go in the 2 directions. Now, let's answer their questions. They're going to say, if I can get rid of all this now so I can have room to answer the questions. They're going to say, what's the domain, aren't they? Let me read this. Find the domain. So remember what, now on a picture, for a picture, remember we have domain for equations, where you got to like denominator can't be 0, can't have negative inside of a square root. But domain for pictures, how do you domain for pictures? What do? You just look at the thing. You go left edge, right edge, right? Domain just means how far left does the graph go, how far right does the graph go. Well, this piece goes forever left, and this piece goes forever up and right. So negative infinity to positive infinity. So that's the domain. Domain is, remember, left edge, right edge. So that's easy. From the picture, domain's cake, right? Forever left, forever right. Next question. Locate any intercepts. Intercepts. So do you see any places where it hits the grid lines? Right there. That's the only place it hits. It never hits the x-axis, does it? But it hits the y-axis right there. Intercept 0, 3. Easy, huh? When you have the picture's worth 1,000 points, right? Picture worth 1,000 words. Choose the correct graph. Well, they give you multiple choice. You grab it. Based on the graph, find the range. Yeah. How do you do range? What's range? Range is bottom top. Range is up down. How low does it go? How high does it go? Right? Let me write it over here. Range is bottom, comma top. Like domain's left right. Range is bottom top. So what's the bottom? What's the lowest that graph goes?
2.
2. And what's the highest? Infinity. Bracket 2, comma infinity, right? Because you hit 2 right on the money. Comes down to 2 right on the money. Goes up to infinity. Top is infinity. Done. Right? So the graph, all the other questions are simple once you have the picture. Good on that one? Let's see if we can do 1 or 2 more. Time for all of them. All right, let's try this one. So they're all kind of good. They're all valuable. Make sure you do them all and really come to understand them. So 2x plus 7. I don't create just throwaway homework problems. I'm really intentional in the homework problems. They do become test questions. Things just like them. So, okay, we have 2x plus 7 for that one. And then 8 for x is 1. And then minus 2x plus 6 for x greater than 1. Okay. So there we go. So give that a try. So to draw a big graph, break it up, where it needs to be broken up. Okay, so the red graph goes from -3 to 1, huh? From here to there. And so in this zone is the 2x plus 7 graph, right? And then the blue graph is just at 1. And then the purple graph goes from anything greater than 1. So the purple graph goes, from 1 and onwards, so minus 2x plus 6. So the wall of separation
Is that 1 again?
is at 1 again, isn't it? Everybody good with that? That making sense? So we'll use 2x plus 7 left between -3 and +1. And we'll use the purple graph, -2x plus 6 to the right of that. So go ahead and do that. So you want to get a point right at the wall. So make your table and plug in x equals 1 and x equals 0, 1 off of the wall. And then for the purple graph on the right, x equals 1 and x equals 2, right at the wall and 1 off the wall. But then also, what happens right at the wall? The function's just up at 8. You just do that right now. You just put that dot down there. It just simply is at up 8. How high is this graph going to go? Let's go up to 9, and then, yeah, so I better go up to 9. Okay, so I'm going to make these smaller. 1, 2, 3, 4, 5, 6, 7. Didn't make them small enough. 8, 9, so it goes up to 9. Anyway, 8, so I can just put this right here, right now. That's over 1 up 8. Everybody see that? See how I came up with that? That's for sure. That I just handled the blue graph. That's really all there is to the blue graph. He's a single dot, isn't he? Everybody see how I did that? When x is 1, f, which is y, is 8. When x is 1, y is 8. So over x is 1, y is 8. Solid dot at over 1 up 8, right on the wall. So there's the blue graph, the middle graph. Now just do the red to the left and the purple to the right. So for the red to the left, I'll make a little XY table. So what am I going to plug into the red equation?
1.
This is going to, I'm going to go right to the wall, 1. And this is, the red one is y equals 2x plus 7. So plug in right at the wall, 1, and then 1 off the wall, so that'd be 0, huh? Plug in 1 and 0. Or you can plug in 1 and -3 if you want. It doesn't matter. Yeah, maybe that'd be better. Since there is an actual edge, it doesn't matter. You could do any. But since there is an actual edge to this one, actually stops. He doesn't keep going like the last one. He does on the right. He goes forever to the right. How do I know? Greater than 1. That's just on and on and on, huh? But on the left side, he stops at -3, doesn't he? Mm-hmm. So he actually has a left edge. That's different than the last problem. So I'm going to go ahead and go all the way to his left edge. Probably more useful. Whereas if it goes forever, just do the wall and 1 more, But either, you could do 1 and 0. It's okay. Doesn't matter. Plug it in. What do you got? 2 times 1 plus 7, that's 9. Plug in the -3. 2 times -3 plus 7, that'd be 1. So -3 up 1. Oh, and I should circle the 1, 9 because it's an open dot. He doesn't quite make it to the wall. He's only less than 1, not equal to 1. Everybody see that? You still got to go to the wall because he gets infinitesimally close to it. Open dot. Over 1 up 9. So he's right here. Look at that. At 9. Open dot there. And he goes down to there at back 3 up 1. And this dot is over 1 up 9. Everybody see that? Open dot. Over 1 up 9 comes down to negative back 3 up 1. That's the red part, the left part. Mm-hmm. No arrows. He stops here. Solid dot, right? He's equal. That's an equal to -3 there. Good. And now the part on the right. The purple graph, I'll make a little XY chart over here. Plug in, I'm just going to plug in the wall, which is 1, and 1 more, 2. I'll just do 1 and 2, because he goes forever to the right, just 1 and 2. plug it into what function? Negative 2x plus 6. Whoops, I need a little more room, don't I? So negative 2x plus 6, plug in 1 and 2. Negative 2 times 1 plus 6 was that? 4. And negative 2 times 2 plus 6, 6 minus 4, 2. So over 1 up 4, open dot. Circle this one, because again, he's greater than 1. He's not equal to 1. So circle the 1, 4. It's an open dot. Over 1 up 4, and then over 2 up 2, solid dot. So over 1 up 4, over 2 up 2, and forever that way, huh?
Wait, it says negative, that would be negative 2, not 2. Because there'd be negative 8 plus 6.
Negative 4 plus
Oh,
6.
never mind.
Over 2 up 2.
Oh,
We
I have
good?
4 in there.
And it makes sense it goes down. Look at that negative slope. Of course that line's going down, huh?
Everybody must be more tired than I thought.
So there's the graph. We can answer all the questions. Let me just do them verbally. What's the domain? How far left? Negative 3. How far right? Infinity, right? So the domain, left edge, right edge, negative 3 to infinity. What's the range? How far down? Forever down. How far up? 9. And not quite, it doesn't touch 9. So the range, a little tricky there. Range would be negative infinity up to 9, but parenthesis at the 9. It doesn't quite hit the 9, does it? Right? Intercepts. Yeah, you got to find this intercept. I don't know where it hits. You can plug into the red equation to find out where that hits. So the red line hits it, and the purple line hits here. You got to plug in to those equations. Remember how you find an intercept? Hold on, we got at least 2 minutes. We need these 2 minutes. These are valuable. You got to plug. Remember, to find intercepts, you plug in the opposite letter 0. Right? I just don't got time to do all that. I want to look at one of the backwards ones with you real quick. So, you got to plug in. This point has a height of 0, doesn't it? So you got to plug in y is 0 to the purple equation. Plug in y is, and plug in 0, and solve. What's the answer? It's 3, right? Move the minus 6 over, divide by the minus 2. You can read any of that. It's 3. So it actually hits at 3, even though my graph doesn't look so good. So I'll come see me. I'm sorry, I just don't have time for everything. Less whole thing, but just this. It's going to basically be 3 plus x less than 0. So 0 is your wall on this one. X equals 0. It's going to be 3 plus x, which is, I'll just show you real quick. When x is 0, it hits at 3. It's going to basically be like that. And then open dot there. Whoops. Open dot there. Open dot. And then to the right, it's going to be this equation greater than, it's going to be x squared. So it's going to go like this. This is y equals x squared for values greater than or equal to 0. So that's what you're going to see on that thing. It does a U shape on one side, straight on the other.